to Vedic mathematics, but even though he is working with these parameters, so that's why we have introduced this kind of a speaker actually. His list of publication is based on an algebraic approach to Q partial fractions in Sylvester denumerations. The Ramanujan Journal has been accepted this paper. It is the extension of Paravartya Yojayate Sutra. 16 years teaching experience at university level. He has taught many type of students like BSc, MSc, MTech students. He has taught measure theory, advanced algebra, category theory, लीनियर ट्रांसफॉर्मेटिक्स में एसोसिएट प्रोफेसर हैं और मैम का जो टॉपिक जो मैम जिस फील्ड में काम करती हैं वो मैथमेटिक्स के साथ में वैदिक मैथमेटिक्स भी है तो मैम इज एक्सटर्नल गाइड ऑफ वैदिक मैथमेटिक्स आल्सो therefore we have suggested to ma'am that must chair this session. Please welcome ma'am. Over to you ma'am. You would like to say something?
Yes, मैं आपको सुन पा रही हूँ. Thank you, Sonia.
Thank you, ma'am.
We welcome Shri Uday Kiran जी. नमस्कार. आप अभी सोनिया ने आपके बारे में बताया. आप श्री सत्य साई इंस्टीट्यूट आंध्र प्रदेश में आप कार्यरत हैं और आपके बहुत सारे वेरियस इंटरेस्ट की बात करी. आप कोऑर्डिनेटर ऑफ एंशिएंट मैथमेटिकल स्टडीज अपने इंस्टीट्यूट में आप एज ए कोऑर्डिनेटर भी आप कार्यरत हैं. तो आपको हम सुनने के लिए बहुत इस समय ईगर हैं. आप अब शुरू करिए. आप परवर्त्य सूत्र पे कुछ आपका फिलोसफिकल वर्क है. आप अपना व्याख्यान स्टार्ट करिए.
Thank you, ma'am. Thank you to introduce Uday Kiran, sir. Now, sir, over to you. Most welcome, sir.
Am I audible?
Yes, sir.
Yes.
The screen seen?
Yes.
I'm shaking the screen.
You are audible and visible your screen.
Okay. Okay. Om Shri Gurubhyo Namaha. So at the outset, let me thank the university coordinators of the conference, Handa ma'am and Sonia ma'am, and Dr. Sriram sir, who has actually personally invited me. Thank you all for this beautiful opportunity. I could hear few talks, not all because of some other commitments, but I'm definitely enjoying the sessions, and whenever possible I'm also seeing in the YouTube the recorded sessions. So you're doing such a wonderful job. Thank you for the good coordination and organization. Okay, I would like to tell about myself briefly. First of all, forgive me, I'm not speaking in Hindi, though I would like to discuss my Hindi itna swachh nahi hai, shuddh nahi hai, so I will speak in English. And
problem, sir? Not at all. You can speak in English.
Okay,
there's no problem.
Thank you. Okay, so to be very frank with all of you, I'm not definitely not a Sanskrit scholar, not a scholar in ancient Indian mathematics, not well versed in all the sutras of Shri Bharati Krishna Tirthaji Maharaj. Although I am a mathematician who is curious about Indian philosophy, I am coming from a place which is in some sense a hallowed place for spirituality. So that actually draws me to the Bharatiya Samskriti and Indian philosophy. Although I have done a small piece of work in number theory relating to Paravartya Sutra, and that's exactly what I want to share. That paper is also published in the Ramanujan Journal. So I want to discuss the philosophy behind it and actual practical implementation of that. So the structure of my presentation will be, broadly speaking, in three parts. The first part would be discussing the philosophy of Paravartya Sutra. Second would be an implementation of this sutra. And third would be understanding the mathematics behind. Leading speakers on the first day, Professor James put it, without understanding the mathematics of the methodology and procedure, the sutra is not complete. And in that sense, I also would like to put the mathematics behind. And of course, I will not go deep into it, but you will realize that there is a lot of deep mathematics. And those who are pursuing Indian mathematics and Vedic mathematics, you are doing great service to the nation, and by bringing out a lot of our treasure. In the philosophy of Paravartya Sutra, you should look out for one particular slide, which will be the main slide. I will title the slide as The Philosophy. And in the implementation of the sutra to higher degree polynomials, such a work is not done before. In the book, the beautiful book Vedic Mathematics, Swamiji has written for the linear and powers of linear case. I have taken inspiration from that book and then extended this to higher mathematics. Now, I should also tell you the background. As a school student, I was very much intrigued by the book of Swamiji, and I used to do a lot of some so-called shortcuts and the mental gymnastics associated with these calculations. And always the kind of speed with which we do, and the kind of rigor that brings in, and also the kind of beauty of mathematics that is brought out is something which has intrigued me a lot. By God's grace, I went on to do a PhD in mathematics, and I learned some significant amount of modern mathematics. Later, when I started looking at these sutras, then I realized that the sutra my best, and then it turned out to be a success. And I want to share that success story also with you. So the principle of Paravartya Sutra mainly is used for arriving at efficient methods for division, remainder, and partial fractions. So the objective of my talk will be discussing an application of Paravartya Sutra for higher degree polynomials and bringing out the mathematics behind. So the contribution of the presentation would be extending the shortcuts for higher degree polynomials, building a theory based on the branch of mathematics called commutative algebra. So if you actually sit with the book of Vedic mathematics and then try to unearth what exactly is the key point in that book, one glaring feature, one significant feature that comes is many problems which are arithmetic problems are converted to algebra problems. And once we have algebra, a lot of power can be harnessed through the identities of algebra. And once we have the identities which give us a simplification, we get one-line mental shortcuts for arithmetic operations. And this is the principal point on which Swamiji has developed these 16 sutras, and they give you, as Professor James also put it, the mental efficiency, the way we think about mathematics are encoded in these sutras. Paravartya Sutra is a beautiful example to illustrate the interplay between arithmetic and algebra. So, one of the key points is we have a number, and the notation and the symbolic computations Swamiji has given us actually make us understand that the number indeed can be treated as a straightforward polynomial. Now that is actually not true if you take a number in general. For example, if I take the number 18, I have 1 and 8. It is 10 plus 8. But if you take a general polynomial, it is something like ax plus b, where a and b are not necessarily positive numbers. Now, to address that, a very interesting notation is created in the book. It is called the vinculum notation, and also Paravartya division. So, to get started, I will discuss these two on the screen. Okay, can you see the screen? Yeah, so if I take 18, 18 is 20 minus 2. So 20 minus 2 is 2 into 10 minus 2, which is written as 2 bar. So this gives us a lot of efficiency. In the first place, if you have digits greater than 5, they can be reduced to less than or equal to 5. Second is, you also have the concept of negative number. Excuse me, Sonia ma'am, is this clear?
Yes, sir. Yes, sir.
Screen is clear, right? Okay, so this is about the vinculum notation. And if you take the number, so I took 432 dividing divisible by 11, dividing 432 by 11. So the idea behind Paravartya Sutra is, first of all, you should take the number, the decimal number, a power of 10, which is close to the number. So in this case, it is 10. So if it is 10, then we draw a line here, and then because it is 10, we take the 1 digit as a possible reminder. We can also have 2-digit number as a reminder. Then what we do is, we take this 11 and the last digit. So this becomes 10 plus 1, and we take the plus 1 as 1 bar, as minus 1, and that is basically the transposition, which I will explain later. I'm sure some of you are very familiar with this. I'm just doing it for the sake of some recalling. So first we write the 4 as it is. Then we multiply the 4 with 1 bar to get 4 bar. And then when we add, we get 1 bar. And then 1 bar again is multiplied, and we get 1. Minus 1 into minus 1 is 1. So I get 3. So we notice that we have 4 1 bar as a quotient. In turn can be thought of as 4 into 10 minus 1, which is 39. So when we divide 432 by 11, we get quotient as 39 and remainder as 3. So essentially this is Paravartya Sutra, and we notice that we are able to play with numbers because we are also able to consider positive as well as negative numbers. So therefore, we are able to get a polynomial view of a number, or in other words, we are able to convert the arithmetic number problem to that of a polynomial like problem. Therefore, I will focus in this presentation only on polynomial arithmetic. I will not go into numbers. So Paravartya Sutra starts off with this remainder theorem. If you go to the book of Swamiji, it will start with remainder theorem, where I am dividing a polynomial f of x by another polynomial x minus a. What we do is, in remainder theorem, the remainder is simply substituting x is equal to a in f. That is the remainder, which basically is I have an equation setting x minus a equal to 0 and take the a to the right hand side. Or in other words, I am transposing the rest of the terms to right hand side with, if there is a negative sign, it becomes positive. If there is positive, it becomes negative. If there is multiplication, it becomes division. Division becomes multiplication, so on. So we transpose the sign of a in x minus a from minus to plus and then substitute it into f. So in some sense, we can call this method as